Okay, good morning, everyone.
Good morning, sir.
So, today we will start with the next topic, which is differentiation under integral sign, abbreviated as DUIS. So, differentiation under integral sign, or short form DUIS. Again, this is the next rule to find out or to solve the integration. Say for an example, I'll write down a simple example and we will see how this is actually used. Say for an example, we need to evaluate integral 0 to infinity sine x upon x, sine ax upon x. So integral 0 to infinity sine of ax upon x dx. Suppose this is what I have to evaluate. Can someone tell me the answer will be a number or it will be some function of some variable or what it is going to be? This has to be equal to. If you solve this integration, will you get a number?
No, sir.
That will be
No, sir.
that will be a function in terms of will be a function of
In terms of n.
integration 0 to infinity sine of ax upon x dx. So integration is with respect to x. Limits are going to be for the x. Whatever answer you will get, that will be in terms of this a. Okay, so that's why I of a is equal to 0 to infinity. Now, there is no rule, I mean, by which you can actually evaluate this integral. Depending on your 12th standard knowledge, you cannot solve it. If you have any idea, please let me know. So, I don't think you can solve it because even integration u into v rule that will make this complicated. Uh, Say for an example, I'll take the derivative d by dA of I of a. So this is equal to integral 0 to infinity d by dA. Look, this is actually wrong. So if I write down the d by dA, I have to write down the d by dA outside. Sine of ax upon x dA. Look, integration is with respect to x and derivative is with respect to a. So these two won't cancel out each other. Okay. So if by some rule I can take this d by dA inside. So what we will have integral 0 to infinity derivative with respect to a of this term. And that will be cos of ax upon x into x dx. This is the derivative of this term, sine of ax upon x. So this 2x gets cancelled out, and what is the integration now? The integration of cos of ax is sine of ax divided by a. Uh, oh, I'm so sorry. Integral 0 to infinity. Okay, so and this is how, I mean, we have evaluated this. So here I'm not getting the answer actually at infinity sine of a infinity. So the question which I started with it is wrong. But I hope the idea is clear. So we have some integration which you cannot solve directly. But you can observe that if you take the derivative of integrand with respect to the parameter, then it is solvable. Okay. So in this type of cases, what we do is we use the so our topic is going to tell us in which cases I can take the derivative inside, the cases in which I cannot take the derivative inside, and if I want to take, what extra terms I will have to add. So this kind of things we are going to study. So there are only two basic rules. The rule number one says that rule number one rule number one is if I of A is equal to just a minute. If I of alpha is equal to integration A to B f of x comma alpha dx, where A comma B are constants, means that those are some numbers, then di by dA is equal to integration A to B dabba f. Oh, this has to be alpha, sorry. We have I of alpha, so derivative is going to be with respect to alpha. D partial derivative of f with respect to alpha d. So what conclusion we are drawing? Anyone, can you explain this? Rule number one. Anyone who can give it a try? So what does the rule number one is trying to tell you? Is the rule number one trying to tell you? Yes, please.
If a function has a two variable, then we have to take one constant and differentiate.
Okay. Anyone else? So rule number one is trying to tell you that if your limits are constant, okay, if your limits are constant, A and B are constant, lower limit and upper limit are constant. And if you take the derivative of I with respect to alpha, then the derivative can be taken directly inside the integration if the limits are constant. Remember that A and B, they are saying that those are constants. Then I can take the derivative inside the integration. This is rule number one. I'll write down the rule number two now. So rule number two states that if I of alpha is equal to,
Sir, I had a doubt, sir.
yes,
Sir, in any question, if we do these things, like if A and B are there
hmm,
as the sir, can you shift to the previous slide once?
okay, yes, huh,
Yes, sir. If we take any question
hmm,
in which A and B are given,
hmm,
then after the it applies to every question, right, sir? Then
yes, yes, of
because we
course.
have to first differentiate and then we will put the I mean adjust the limits accordingly, right?
No, no, you don't have to adjust the limits. Limits are constant. then you can take the derivative inside. That's all this rule is all about.
So then in substitution, if we try to substitute it, then the limits will change, right?
Yes, substitution is a different story, na? In this rule, we are just talking about when I can take the derivative inside the integration, and when the limits are constant, I can take the derivative inside the integration. That's all. We know that derivative and integrations are opposite of each other. So if we have d by dx of integration f of x dx, so derivative भी with respect to x है, integration is with respect to x. These two cancel out each other, and what you will get the answer is f of x plus integrating constant sum c will be there or not. So if these are definite integrals a to b, then derivative and integration cancels out each other, because derivative is with respect to x and integration also is with respect to x. But you can see that here it is not the same story. Your integration is with respect to x and you're taking derivative with respect to alpha. Okay. So in this kind of cases, I can take the derivative inside the integration if and only if both the limits are constant. That's all. Rule number one. Here we are just going to talk when I can take the derivative inside and when I cannot. Am I clear?
Yes, sir. Yes, sir. Got it.
So rule number two. If I of alpha is equal to the integration a of alpha to b of alpha f of x comma alpha dx, where a of alpha and b of alpha are functions of alpha, then di by d alpha is equal to di by d alpha is equal to integration a of alpha b of alpha d dabba by dabba alpha of f of x comma alpha dx plus f of b of alpha comma alpha into b dash of alpha minus f of a of alpha comma alpha a dash of alpha. So rule number two looks a bit lengthy, but it is quite, I mean, easy to remember. So rule number two states that if your limits, again here, you can see that a of alpha, your lower limit and upper limit are the functions of alpha. So in that type of cases, you cannot just simply take the derivative inside and go for solving. No. When your limits are functions of your alpha, in that case, I will have to take the replace x by upper limit multiply by derivative of upper limit minus in the integrand replace x by lower limit into derivative of lower limit. So this is the statement for rule number two. So rule number two is to be used whenever your limits are the functions of alpha. Those are not constants. In that case, we will have to use the rule number two. Fine. I hope the two rules are very much clear and I can go for examples on this. Example.
Sir, previous slide, sir. Okay, sir.
Example. Evaluate integration 0 to 1 x raised to a minus 1 upon log x d. So you have log x in the derivative. Directly you cannot solve this. You can try if you want, but you can see that it is not solvable. So integration, if you take of this, the integration is with respect to x. Your answer will turn out to be in terms of a. So I of a is equal to integration 0 to 1 x raised to a minus 1 upon log x. So idea to recognize when you have to use the DUIS. Can you take the derivative of numerator with respect to a? What is d by dA of x raised to a minus 1 upon log x? Anyone? Derivatives with respect to a, log x will come outside, being constant. What is derivative of x raised to a minus 1 with respect to a? What is the derivative with respect to a?
X raised to a into log x.
X raised to a into log x is to a log x. So this will get cancelled out. Fine. So ये जो अंदर की term है, this will directly be x raised to a. जिसका integration is very much easier to solve. Okay. This integration I can solve, whereas this was difficult. So in this type of cases where taking the derivative will simplify the statement differentiating with respect to a. So we'll have di by dA is equal to d by dA of integral 0 to 1 x raised to a minus 1 upon log x dx. Which rule we have to use over here? Which rule is to be used? Rule number 1 by rule 1 of DUIS. What do we have? di by dA is equal to integration 0 to 1. Derivative, we saw that it is x raised to a log x upon log x d. So integration of x raised to a with respect to x is x raised to a plus 1 upon a plus 1 0 to 1. So this is 1 upon a plus 1. So what have we got? di by dA is equal to 1 upon a plus 1. What value do we need? We need the value of I of a. Look at this. I of a is something that you need. Okay, that is the value of this integration. So I will be equal to integration of 1 upon a plus 1. This integration will be with respect to respect to a. So integration of 1 upon a plus 1 is log of a plus 1. That's it. Is there anything else? Is there anything else?
Sir, how you know that the signs of integral is function of a?
What? I'm not understanding.
Sir, in second line, sir,
Hmm.
how you know the integral is a function of a?
So what things do you have in integration? इंटीग्रेशन इंटीग्रल में क्या क्या है? देयर इज
Sir,
a, देयर इज log x, और x की वैल्यू तुम पुट कर दोगे. इंटीग्रेशन इज विद रिस्पेक्ट टू x, so the limits are for x, तो x तो निकल ही जाएगा. बचा क्या? क्या
a
बचा है? a.
is
हाँ, so answer will be in terms of a, है ना?
yes, sir.
Is there anything else? Someone? Is there something that I am missing over here?
Integral
Yes, Rohit.
integral constant.
Integrating constant, exactly. So this integration that you are doing here, this is indefinite integral. So we need to put the integrating constant. But we have to figure out a way by which I can find out the integrating constant. Is there some value of a by which you will get the value of I easily? Can you put value of a by which you will get this integration easily? For a equal to dash, then I will become dash.
0.
So if you put a equal to 0, then what you will get? I equal to 0, right? So x raised to 0 will become 1, 1 minus 1, 0. Integration of 0 is 0. So we'll put this in this equation. Put in star. We get t equal to 0. And so the value of I has to be log of a plus 1. This is the common silly mistake that I have seen so far. Students forget to put the c. In some cases, this integrating constant turns out non-zero. In this example, particularly of this example, you got the integrating constant as 0, so it didn't make a lot of difference. But in some examples, that can become non-zero. So you have to take care of this integrating constant. Next example. Assuming, okay, anyways, prove that integration 0 to 1 x raised to a minus x raised to b upon log x and dx is equal to log of a plus 1 upon b plus 1. It is given that a comma b are greater than 0. What is the difference here? The difference is now we have two unknowns. I mean a and b, right? So I'll assume that suppose if it is I of a equal to integration 0 to 1 x raised to a minus x raised to b upon log x dx. I'll go by our regular method. I'll take the differentiation with respect to a. Differentiate with respect to a. So I will get I dash of a is equal to, by rule number 1, I can directly take the derivative inside. So derivative of x raised to a minus x raised to b upon log x with respect to a, that is going to be x raised to a log x upon log x dx. So this 2 gets cancelled out. What do we get? I dash of a is equal to 1 upon a plus 1. I have skipped 2 steps here, but doesn't matter. It's quite similar to the example number 1. So what we will have here, I of a is equal to
Sir, derivative of x raised to b.
derivative is with respect to a, so x raised to b का आंसर क्या आएगा?
A constant 0.
Yes. So I of a is equal to log of a plus 1 plus c. Now what you will put? So this is kind of a program that we are running. Say consider let a is equal to b. A is equal to b, right? Then what is the value of I?
0.
Becomes 0. So if you substitute this here, so 0 is equal to log of b plus 1 plus c, right? So c is equal to minus log of b plus 1. So if we substitute this, so I is equal to log of a plus 1 minus log of b plus 1. So I will be equal to log of a plus 1 upon b plus 1. Right?
Sir, I have a doubt.
Yes.
Sir, in this problem, there were two constants, a and b. So we differentiated it with respect to a. What if we did? What if we differentiated it with respect to b? Then will the answer be same?
Yes, yes, of course. Still the answer will be same. If you differentiate with respect to b, you will get x raised to b log x over here with minus sign, right? So I dash of a, I dash of b will become minus 1 upon b plus 1. This is what you will get. You can see that it is taking care of this minus sign. And then you will get c is equal to log of a plus 1. Am I right?
Yes, sir.
So the same thing will be followed. Next example. Just give me a minute.
Sir,
Okay. Next is.
sir, I had a doubt.
Yes.
Sir, how do you know that we have to take a is equals to b and then do the.
Because for a equal to b, I can find the value of I. Na?
Sir, but if we keep anything like b is equals to 0, still
Then
we
you will
will.
get x raised to a upon log x. You cannot find the integration. Our task is, or our aim is to get the value of I easily. This value I should know. So according to that, you put the value over here. if you put b equal to 0, say for an example, if you put b equal to 0, you will get x raised to a upon log x. You have to solve. I don't have that much time. So you put a equal to 0, you will get minus x raised to b upon log x. So you have to think in a manner where you can easily solve this integration. In the previous example, if you put a equal to 0, you are getting this whole integration as 0. Am I right? So if you put a equal to 0, this complete thing becomes 0 and the value of I is 0. So you have to think of a value by which you can find the integration orally. Are you convinced?
Yes, sir. Yes, sir.
Fine. If capital F of t is equal to integration t to t square e to the power tx square dx. Then find df by dt. So you have f of t. What is f of t? F of t is equal to integration e to t square e to the power tx square dx. Differentiating with respect to t. Df by dt is equal to d by dt integration t to t square e to the power tx square dx. Which rule here? By rule number 2, because in this you can see that your limits are in terms of t, and so I cannot simply take the derivative inside. So t square derivative of e to the power d by dt, I'll write down in detail as this is first example of rule number 2. Dx was the further plus in the integrand at the place of x you put the upper limit, so that will be e to the power t in bracket t square whole square into derivative of upper limit, that is 2t, minus at the place of x you put the lower limit is t whole square into derivative of lower limit, which is 1. So df by dt is equal to integration t to t square, derivative with respect to t is e to the power tx square into x square d plus two t into e to the power t raised to 5 minus e to the power t cube. What about the first term? What about the first term? Integration of e to t square e to the power tx square into x square dx. We'll have to use the UV rule. I'll use the generalized UV rule over here. The generalized UV rule says that What is the integration of e to the power tx square with respect to x? So that will be e to the power, oh, I'm so sorry, tx square it is. It will be very much difficult. But no problem actually. Okay, so that will be x square, integration of e to the power tx square. So that will be capital F of t minus the derivative of x square is 2x, again an integration of f of t, integration of f of t dt. And the next term will become plus 2 times integration of f of t dt. This is what we will have. But integration of f of t, that is becoming a bit complicated. Okay, so let's not bother about this. We'll skip this part. I'll take another example which can be easily solved. This generalized UV rule too, I haven't given you by now, I guess. I've given you generalized UV rule. Hello.
No, sir.
Okay, fine. Even that I will have to tell you. Anyway, so we'll skip this example. We'll go for another example. Show that d by dA of integration under root a to 1 upon a cos of ax square dx is equal to minus integration under root a into 1 upon a x square sin of ax square dx minus 1 upon a square cos 1 by a minus 1 upon 2 root a cos of a. So consider the LHS. What is our LHS? LHS is equal to d by dA of integration under root a to 1 upon a cos of ax square dx. By rule number 2, I can take the derivative sign inside, but with that, I'll have to add the further terms. So this will be integration root a to 1 upon a. Derivative of cos of a square is ax square is sine of ax square. And by chain rule, derivative I'm taking with respect to a, so we'll have x square dx plus in the integrand at the place of x you put the upper limit. So what is the upper limit? 1 upon a. So a into 1 upon a whole square and the derivative of upper limit which is minus 1 by a square minus in the integrand you put the lower limit a into root a square by chain rule, oh sorry, not chain rule, into the derivative of lower limit, which is 1 upon 2 root a. So if you simplify this, so that is integration derivative minus sin a square, it has to be. So this is minus the root a, so 1 upon a sine of ax square into x square dx. In this you will have minus 1 upon a square cos of 1 by a. And the third term minus cos of a square 1 upon 2 root a, which is equal to RHS. So this is how we apply the rule number 2. One example you can try, is quite easy actually. Look, on rule number 2, a lot of examples can be created by just finding out the derivative and giving you 4 options.
Excuse me, sir.
Yes.
I'm still not done with the previous slide. Just a minute.
Okay.
It is done, sir.
Evaluate integral 0 to infinity e to the power minus x upon x. 1 minus e to the power minus ax dx. Yes, can you try this? Of course, I won't leave you, but I'll give you the milestone steps, like directly what is. So if this is equal to I, what is di by dA? So you can try first of all, what is di by dA? Yes, anyone? Sumedh, Sahil, Siddhi.
Sir, e to the power minus 6 into e to the power minus ax.
No, I guess.
Sir, e to the power minus 6 into 1 plus a.
No.
E to the power minus x into e to the power minus ax.
You are telling me the integrand after taking the derivative. What I need is after the integration, what you get. What you are saying is it is integration 0 to infinity, then you will have e to the power minus of a plus 1 x dx. This is what you are telling me. I don't want this. Solve the integration and tell me simply what is di by dA. No one can solve this integration. What is difficult in this?
Sir, the answer is very absurd. Something really
Sir, we
different.
get the two integrations in intermediate सर. मतलब dx भी मिल रहा है और dA भी मिल रहा है सर, तो उसको कैसे सॉल्व करें?
You cannot solve this integration. What is
Yes,
integration? Integration of e to the power 3x dx. What is it?
e to the
What's the
power 3x upon 3.
ah? So what's the problem here? Tell me. What is a plus 1? It is a constant. So it will go in division. What's the problem with integration?
Okay sir.
So when you put the upper limit infinity, the answer will turn out to be 0. When you put 0, the numerator will become 1. So it is 1 upon a plus 1. What is difficult in this? I don't know what confused you so much so that you are not able to solve such an easy example. So from this, I will become log of a plus 1 plus c. What is the value of a that you will put?
Sir, minus sign.
My question is, what is the value of a so that you can find the value of I easily? Yes.
Sir, sir, 0.
Yes. So put a equal to 0. Then you can see that e raised to 0, that will turn out to be 1. 1 minus 1, 0. So I becomes 0. So 0 is equal to log of 1 plus c, which tells me c equal to 0. So I is equal to log of a plus 1. That's it. This is the end of DUIS. There is nothing else in the DUIS. I hope you are solving examples from the question banks for whatever we are studying here. Fine, we will stop here. Thank you.
I need to start.
Oh.
These are not so much.
Sir,
Yes.
attendance link, sir.
सर वो माइनस साइन रहेगा ही शायद.
कहाँ पे माइनस साइन रहेगा?
di by dA is equals to.
No, that is correct. Minus sign cancel होगा ना when you will say upper limit minus lower limit.
Yes, yes sir.